Hello, my name is Delio Jaramillo-Velez. I am currently a graduate student at CINVESTAV in Mexico City. My advisor is Rafael Villarreal. I'm currently on the academic job market. I wanted to tell you a little bit about my research. So, my research interests are in coding theory and commutative algebra and their connections with combinatories and geometry. At the moment, I'm interested in questions pertaining to evaluation codes. These codes have an algebraic structure, and I bring tools as the degree of Hilbert-Sumner multiplicity, properties of vanishing ideals, and grounded bases to study their duals, minimum distance, and generalized Hamming weights. Some examples of these codes are algebraic geometric codes, Ring-Muller-Tai codes, and monomial codes. As a particular case, we have computed the minimum distance of a toric cove over a hypersimplest. These coves are defined using square-free homogeneous polynomials of degree d. This formula only depends on the number of elements of the field, the degree d, and the number of binomes. We have done this using an algebraic description of the generalized Hamming weights in terms of the Hilbert-Sumner multiplicity of the vanishing idea. Another area of interest for me is algebraic combinatorics. Here I explore algebraic properties of H ideals, binomial H ideals, and their powers, symbolic and ordinary powers, from a combinatorial point of view. I like to understand algebraic invariance using concepts from combinatories. For instance, I work on the computation of the B-number and Castelnuovo-Mumford regularity for these ideals associated to graphs. In this direction, we found a necessary condition for the Cohen-Macaulayness of the second symbolic power of an H ideal. This is a combinatorial condition that means that the graph is H-critical. This graph, for example, is a H-critical graph with 6 vertices, so that his H ideal has a squared symbolic power Cohen-Macaulay. Finally, I enjoy to study prime characteristics. I focus on singularities in prime characteristics, in particular on F threshold and test ideals, and the relation with the low canonical threshold. I look for effective ways to compute the effective threshold of hyperspaces and ideals. For instance, I am currently interested in compute the effective threshold of a binomial H ideal. The work that we have done here is find an explicit formula for the pure thresholds of Thom-Sebastiani polynomials. These polynomials are assumed polynomials in different sets of variables. And we present a formula that relates the expansion modulo p of the terms in the Thom-Sebastiani sum. Thank you for listening. If you are interested, please reach me by mail or visit my webpage for more details. Thank you.